Good morning, folks. If you want to see the slides better, you might want to move up front. I know sometimes the slides can get a little bit small, and it's much easier to see them without having to pull out your binoculars in the back. So let's get started. My name is John Rath. I'm Director of Operations. I see a lot of faces that were here yesterday, so I won't go over the details of getting the credits for this course. If you're interested, please see me in the back at the end of this session. It's very important that we get your signature on one piece of paper or another so that we can submit your name for the credits. If you have not registered for the credits on our NY-GEO website, you'll need to do that after we get your signature or even before on the piece of paper. But the piece of paper is the real critical point, or else I've got to come visit you in the next month or so wherever you live to get your signature. Well, today, this session is about a preview of the C448 binational standards, and I can't think of two people with more experience and more passion for quality control and standards than the people that are going to talk to you today, Lisa Meline and Mark Metzner. Lisa is the principal engineer and owner of Meline Engineering, in Sacramento, California. And way farther north is Mark Metzner from GreenStorm GeoExchange Consulting up in our neighbor to the north, Canada. They have lots of experience, even though they don't look like they might be at that level. Probably around 50 years of combined experience dealing with standards and making sure that our industry does what it's supposed to. Lisa is licensed in 4 states, and she's an ASME fellow and founding member of the California Geothermal Heat Pump Association. Mark has got 2 decades of ground source heat pump installations and lots of leadership roles seeking to raise the standards in both countries, including ANSI, CSA, IGSHPA, and basically has lots of experience in almost all aspects of geothermal installations. I could spend the next half hour talking about their credentials, but I don't want to do that. I want to get Mark up here real quick and begin the program. So please help me welcome Mark and Lisa.
Good morning, everyone. I see we're the most popular track today, are we? It's interesting because this is going to dictate, or not dictate, but guide our industry for the next 5 years, and it could be longer. It depends. So it's unfortunate more people aren't here, but it is what it is. Yeah. What's that, Greg? Well, he didn't do a very good job. That's okay. Going to give a little bit of background on what happened to date, so everyone gets a feel for how the binational standard came into existence. In Canada, we've had a geothermal GeoExchange standard since 1992, and amalgamated from 1992 in 1994 between residential and commercial. So it was the old C445 for residential, C447 for commercial, and in 2002 those were merged together into C448. There's been 2 additions since then in Canada. By way of background, C448 is in the National Building Code of Canada, so it's the law of the land. Not so much here in the United States yet. In 2014, we undertook to make a binational standard between Canada and the United States, and that was published in 2016, and that is the current standard in place right now. We are in the throes of getting the new edition. It'll be probably published in early 2025. January or February is the target date. So that will be the new standard that will be enforced for the next approximately 5 years. It could be longer. I just wanted to kind of dispel some of the myths, I guess, or misunderstandings between what a code is and what a standard is. Standards are voluntary. So you can, voluntarily put your installation into a C448 standard. That's up to you as a developer, or a regulator can adopt that, right? So as an example, Sue, you're from NYSERDA, right? And I think on the balance, you've embraced C448. That said, it's not the law of the land in New York. That would have to go from a code body. So a code is basically the law, and there could be penalties if you breach it. A standard is not enforceable until it becomes a code adopted, by a code body. So that's how this happens. In Canada, like I say, that has been part of our building code since 1992. Should a code body, so an ICC or an IAPMO, adopt C448 as a standard in their area of operation, then it would become the law of the land. At this juncture, that is not true here in the United States. So there's a difference. So just quickly on the agenda, we'll not try to blather on too long. How this came about in the 2025 edition is we looked at the 2016 edition and gathered feedback from industry stakeholders. IGSHPA was pivotal in bringing feedback. There was a whole number of committees that were drafted together and looked at the 2016 editions and made recommendations for the new edition, which have been incorporated. From again, a bit of a background point of view, what's important to understand is when the 2016 edition was formulated, doing a binational standard is not easy, getting everyone north and south of the border to kind of salute, if you like. So the way it was structured is different than what you'll see in the new edition. The 2016 edition had standalone sections, if you like. So if you were doing a vertical borehole heat exchange system, there was a whole raft of standard language around vertical. And it was all contained in one area for vertical, same for horizontal, et cetera. That became somewhat unworkable over time, is you had contradictory messages, if you like, in the different sections. And again, part of that was, I'll shoulder the blame, my mistake insofar as not looking at each section and making sure that there was commonality. That's been rectified. So the basic structure that we're having is a general section, and that has all of the definitions, all of the acknowledgments, and so on and so forth, reference material, et cetera. And then anything that touched more than two of the ground heat exchange configurations. If it touched more than two, it was into the general section. If there was something that was actually unique to a particular section, i.e. a surface water installation as an example, or a standing column well, whatever the case may be, it remained in that section. As soon as it touched two, it went into the general, so we had consistency, so there was no contradictions going, section 3 says that, and section 5 says that on the same topic. So we wanted to get that clarified to the degree that we could, and I think we've done a good job. Just give me a moment. I was trying to say the real highlights here. A number of task force were struck, if you like, and they had the different configurations of ground heat exchangers, but on top of that was the general section, and then we have a commercial section, there's a residential section, and then there's a section that Lisa will expand upon for district systems. And then it went down into all of the different configurations of ground heat exchangers, and then there's informative annexes, which are not part of a standard, they are guidance, nothing more. Some of the areas where we had special task force were for heat exchange fluids, for thermal conductivity testing, and for piping in particular, and heat transfer fluids. So there was kind of like a ghost committees in behind, looking at everything from 2016, updating what had to be updated, basically. I'm not going to read each one of these, but you can read, here are the different sections as it will be in the new 2025 edition. As I said, we have the general, and then we have all of the subgroups all the way down. I will not bother you with reading a slide. I don't think you want to hear that. So that, I'll let you take a peek at it. These are all available for download from NY-GEO. Some of the additions that we put in as well, you see highlighted there in bold, which is interesting, and that's for wastewater. It's an accompaniment, if you like, to ground source heat pump technology and systems. Why it's here right now is it's basically a placeholder, because down the road we envision that it may be its own standard on wastewater technology. There's a lot of different companies out there looking at how you extract that thermal energy from wastewater. We thought it important that it be in this standard now, because it is an accompaniment in a lot of cases to ground source heat pump technology. This may not be in a 2029 edition or whatever the case may be, but we wanted to make sure we touched upon it. And again, Lisa will be expanding on that. One of the areas we spent a lot of time on redoing things was definitions. Now, I know it sounds incredibly boring. However, the same item can have many different terms, but we're all saying the kind of the same thing. So what we wanted to do was ensure that all of the definitions and other definitions, if you like, were within the overall glossary definition category, but we always had consistency, or we do have consistency throughout the standard. We use one term, and if you are used to a different term, you'll see it in the definitions. An example, I guess, would be, borehole or well. So where we call these closed loop, they are a borehole. They are not a well. And we have to make that distinction very, very clearly, because what it does is it muddies the waters, pardon the pun, when you have an inspector looking at a specification sheet, whatever the case may be, and goes, and the spec says, oh, it's a well. Oh, let's get the water well standard out. No, that's going to create all kinds of problems. It's also going to create a lot of extra expense. So we, hammered away on definitions, making sure that we've got as many of the differences in the definitions, but we use a consistent approach throughout the body of the standard. So should you get a copy, please go out and rush out and buy one. You look at it, you don't see what you thought should be a definition within the body, look back to the definition section, and you will find it. One of the areas, again, that we looked at in definitions, you can see it there, the first bullet, if you like, is a designer. There was a lot of back and forth. Is that person an engineer, a designer? What does it actually mean? So if you look at commercial projects, you'll, by and large, always have a PE, or in Canada we call it a PEng. It's the same thing, a professional engineer that will write the specifications, stamp the drawings, and be liable. It gets a little bit murky when you get into the residential area. So you have contractors that will, quote unquote, design a system. And there's nothing wrong with that. However, when you start looking at a liability point of view, who do you go after when something is wrong? So we went and looked at it and said the designer, and I will read this one, is the entity legally responsible for the ground source heat pump system design. So if there's someone, or if a system is not functioning properly or not functioning at all, that designer is the legally responsible entity that you have to, quote unquote, go after. Pardon me. Another area, yes? Well, interesting. Yeah, the question was, is does the person that is doing the design have to have some kind of qualification, correct? A designation qualification. So in the engineering world, as it sits currently, you're a professional engineer and you can stamp drawings if you want. Ultimately, you should be having some specialized training, and Lisa is actually in the throes right now of putting together a, let's call it a revamped version of the commercial design course. And that will be coming out about summer 2025. Yeah, you want the design to be done by someone who's competent, not, oh, I'll try that, right? So there are currently courses available from IGSHPA, from the CGD, which is the Certified GeoExchange Designer. You have a residential designer courses. Lisa's group is redoing all of those, and then that'll be done through an SDO, which is going to be CSA, SDO, pardon me, all these acronyms, the Standards Development Organization, who's accredited in Canada and the United States. So in Canada by the Standards Council of Canada, the United States ANSI, that can give you credentials. So at that point in time, once these courses roll out, that's what a customer, a consumer, a client should be looking for. Does this person have the depth of knowledge and background or not? It's still a free society, so you don't have to, right? Does that answer your question? Yeah. Okay. One of the other areas we looked at that's been causing a lot of heartburn, if you like, particularly here in New York City, and in other urban areas, was this issue of setbacks. How far should a borehole be from a water well, from a sewage line, from a gas line, et cetera? When we looked in the 2016 edition, and again, that's a fatal flaw in my opinion, is we had setbacks that were arbitrary. 10 feet from this, 50 feet from that. And we started looking at it and going, well, why? And where's it coming from? So as we dug through, we found basically there was no rationale that was defensible. So as an example, your borehole has to be 50 feet away from a water well. Well, why not 45? Well, why not 55? There was nothing there. So we kind of re-looked at it and went, yes.
My question is very simple.
Okay.
Myself being a number of years in the design and the operational side of the business, we, in the design organization, we always enforce the codes. The NRC code, NEC code, OSHA code. There are many codes. That's the law. That's a given. You can't get away. You mentioned that we also reference standards, ASME standards, IEEE standards. You mentioned that the standards can become a law. So that means that standards could become a law, but it's not a law. Yet, we enforce the designers to follow those standards. If it is not a law, then how we can enforce? I'm just going back to your original definition. What's the code is and what's the standard is? That's my question is. Question is, we reference, are we doing something wrong when we enforce standards in IEEE standards, ASME standards? So could you please shed some light on that one, please? Thank you.
Sure. I mean, I think ultimately, maybe I was unclear about it. A standard is a voluntary set of guidelines, if you like, minimum standard, and that's the way I should have expanded on that. A standard, by nature, is the minimum standard that you have to adhere to be compliant with a standard, but it's still ultimately voluntary only. It becomes compulsory, if you like, when a code body adopts the standard. Then it becomes law. So there's a bit of a difference there. Am I getting that clear to you or not? I'm sorry.
We enforce standards. Sure, we can't get away. I already said those the codes are NEC code. NFPS code. There's fire protection safety codes.
Mhm.
OSHA also enforces. You can't get away.
Yep.
But you're saying is standards is a guideline. Somebody may follow, may not follow. And that's to me is troubling. Okay?
Yeah, but I guess,
Okay, when we have a UL, United Underwriter Laboratories, when they do the testing of any piece of equipment, they apply standards. So there's other lab, is KEMA lab, KEMA. They also do the testing based on the standard. It's just a guidelines. And the whole world accepts those standards. To me, it's as good as the codes are. But you're saying they could become a law, but it's not a law. We cannot enforce it if it's not a law.
I agree 100%. And when a code body adopts the standard, it then becomes law. Up until that point in time, it's voluntary. Like I made the example in Canada, where C448 is in the National Building Code. We are structured differently in Canada than you are in the United States. We have a National Building Code. The National Building Code of Canada has adopted C448 into the code. It is now the law. In the United States, that has not happened yet. So if an ICC, as an example, or an IAPMO goes, we want to and we will adopt C448 as an example into the IAPMO code, then it becomes the law. Up until that point in time, it's voluntary. Does that make sense?
So right now, I guess, I have a question, and I want to get 5 minutes late, but is it the Wild Wild West?
Just, yeah.
So in New York and the US, is it the Wild Wild West, or should we just use the IGSHPA standard today?
You should be, in my opinion, you should be using the C448 standard from 2016. That's what's in force now,
Okay.
right? So then again, you start looking at different regulatory bodies, and they can say, you will be compliant, as an example, to C448 if you want to be accessing incentive money, right? But that's that's not the law per se, it's a policy. When you have a code body that New York, I believe New York's ICC, I don't know, right? So just as an example, if ICC says C448 will be adopted in full, then it becomes the law of the land in New York, if they are the code body that administers code in New York. NYSERDA, as an example, as a arm of the government, but they can say to access incentive money, if you like, on their programs, they can, I believe they do, say you will be compliant with C448 for your installations. But NYSERDA is not the code body.
Understand. Thank you.
And-
That's
Does that
what I
make
was
sense?
trying to get to. I was assuming that. I just wanted to
And just to clarify, the old IGSHPA standard that we had used for years has been brought in to the C448. So the reason we did that is because a lot of the regulators, the people, code people, didn't recognize the IGSHPA standard because it was an ANSI. So now we're ANSI CSA IGSHPA. Now we're legitimate. We've been peer reviewed. We've gone through the process, so we're legitimized. So that's why we're using this as our industry standard now.
And just as a further note, the IGSHPA standards, once the 25 edition is published, they get sunset. They will no longer be in force. So anything in the United States, you'll be doing, if you want to be IGSHPA compliant, you'll be doing it to C448. Again, voluntary at this juncture. Sorry, Greg.
Yep, and Greg from Con Edison. Just to kind of comment on some of those questions, how we're looking at it as the utility from at least at the standpoint of exploring our thermal energy networks and what the state and public service commission is looking at. And we're looking at this standard to see whether or not this should be part of the regulation, right? There's a potential that at some point we may be required to follow the standard, right? So, as we're designing these projects, we're looking very closely to make sure that, are we compliant with it? Are we in line with it, right? Using that kind of past practices here. So, it could be part of regulation from Public Service Commission, or we as a utility could adopt it to say that, this is our standard, right? We want to design to at least this standard, like we do with gas or electric or steam. So, this is the closest thing that, when it at least comes to the network side, that we've seen that, has this very good detail that kind of hits on really a lot of the systems that we're designing. So this is how we're thinking at it right now. So yeah, exactly to what their point is, nothing is officially tied to it today, but I think some of the state regulating authorities will start to look at this thing and maybe make it something that is required.
Thanks, Greg. Some of the notable changes, and again, as I mentioned, there was these background committees that looked at different aspects, and one of them was the piping task force. So one of the changes that's interesting is that CPVC and PVC, to be standard compliant, will not be containing those materials. Why? There's been a lot of studies done, and there is some real issues with antifreeze agents and CPVC and PVC, the way they are put together, which is basically, it's called chemical welding, but it's actually glue. Same idea, right? You're fusing them, but unfortunately, the chemicals within the antifreeze agents can break down those seals, if you like. So a lot of heartache in the industry, north and south of the border. The piping committee, made up of really, really knowledgeable people, said this is not a good thing to have in these ground source heat pump systems, so it's no longer standard compliant. As a quick note, which I should have touched upon earlier, the standard is performance-based wherever possible. So we don't want to hinder or inhibit any kind of innovation over time. Because bear in mind, we publish in 2025, and the next revision is on a 5-year cycle. In the interim between publishing and the new edition, there can be innovative products come out. We do not want to limit that. That's not the idea. However, there are certain areas where the standard is prescriptive. So with pipe, that's one of them. So basically what you're seeing on the screen, that's what's acceptable in ground source heat pump systems. We don't want people putting garden hose down a borehole, right? I mean, you can laugh. There's some horror stories from the past where, I mean, people put just like, almost like garden hose, the black PVC piping that you use, in your garden, they were in ground loops. That's what the standard's all about. Minimum, remember that, okay? Excuse me. This is, again, a small one, but this is being able to locate your buried pipe. It's interesting and required some clarification. Once we put our pipe in the ground, if it's done properly, it's never seen again. That said, there can be issues, so how do you find it? So we, in the standard, said we have to have some kind of a locating mechanism, which was absent from the 2016 edition. It's minor, but it's there. Excuse me. Heat transfer fluids, and I'm not going to go through this whole list, but you can get an idea of the depth that we did go into, what's acceptable and what's not. There's been a lot of back and forth, and the industry on heat transfer fluid will continue to evolve. So again, a lot of this was simply, here are the performance standards, and if someone comes up with a new magic mix and it meets these performance standards, you're good to go. You will be standard compliant. Again, just a little bit of in-depth where we're sitting now, because remember, heat transfer fluid can be simply water. It doesn't have to have an antifreeze agent. When they do, here's the types that we are saying are, and this is somewhat prescriptive, obviously. This is what's good now, but if you meet the performance criteria with a new heat exchange fluid, you're good to go. Excuse me. Pressure testing is a hot potato in some cases. It shouldn't be, but we looked at through the 2016 edition, and you'll see a lot of engineering specifications where they reference ASTM 2164. Our smartest guys in the room, not meaning me, but on the task force, looked at it very, very critically and came to the conclusion there's a fatal flaw in 2164 when it comes to what a ground source heat pump system has. And we looked at it, and basically it was, looking at the pressure and measuring the pressure at the lowest point of the system. Don't know how you do that at the bottom of a 500-foot borehole. Doesn't work out so well. So what we've done is we've gone through, we've taken the critical elements of 2164, incorporated into this standard so that it is actually doable in the field. Simply referencing 2164 was not adequate. And then we further went with an interim voluntary test, and this is a voluntary standard, and within the standard, this is a voluntary test to test your individual boreholes. The reason we put this voluntary test in, there's been a number of projects where there's a lot of finger pointing going on because you have a drilling contractor who puts in the vertical borehole, loop, and grout, and then they hand off to a tie-in contractor. And now there's this back and forth. Was the loop, or did the loop have pressure integrity and flow or not? If you're not documenting it, there's a problem. So we came up with what we think is a reasonable interim test for the drilling contractor to do that pressure test and a flow test and document it and then hand off to the next entity should that be the construction process. In some cases, one entity is doing the drilling and the tie-in, it becomes less of an issue, but the way the industry is going, people are getting specialized into drilling, tie-in, commissioning, et cetera. So we wanted to make sure there was an avenue where you could ensure the handoff was done with integrity. One of the areas that we've added into for the 2025 edition was the addition of energy piles, energy foundations. It's gathering traction here in North America. Energy piles, energy foundations have been in the UK and in the EU for quite some time, and in Asia they're gaining traction now. So we have another section as a different type of a configuration of a ground heat exchanger, and that's energy foundations. So we've incorporated that as well. I'm going to hand it over to Lisa right now for district systems.
My pictures are prettier. So I'm going to talk to you about two other additions that we added this current revision to the C448. Because of all the activity here in New York around district systems, we really felt like the standard needed to accommodate those. And so we started looking at that as part of the commercial section of the standard and very quickly realized that that wasn't going to work very well. So Chair Jeff Hammond asked me to take a subgroup and work on developing a separate section. And so the first thing I want to mention is that, one of the things about our industry is we call one thing by 5 or 10 different names. And it's really confusing to new people in the industry. It's sometimes confusing to the consumer. And so initially we started calling this the district geothermal system. And then we're like, it really is another district system. It's just another way of distributing energy. And so what I'm going to do is I'm going to read to you this very long definition, because one of the things we're trying to do with this standard is to be inclusive, to give the designers, the developers, the flexibility to define these types of systems based on how they've been in the past and how we're evolving to in the future. So basically, the definition we came to, which was somewhat started from an ASHRAE definition, because the district heating and cooling has traditionally been out of that association. So a district energy system is a system characterized by one or more central plants distributing ambient water, hot water, water-based solutions, steam, and or chilled water, which then flows through a network of pipes to provide hot water, space heating, and or air conditioning for multiple buildings. Central plants are inclusive of pumping stations or plants which can be employed as part of the district energy system using the earth, groundwater, and/or surface water as a source or a sink in the distribution system. And so one of the things, the reason I have this picture up here is this is borrowed from another entity, but what they're showing is all of these things connected. There's all different ways you can put these puzzle pieces together, and we want it to be inclusive of current and future innovation. District energy systems include ambient temperature loop systems, combination systems, and a lot of times those combination systems are warranted because you're trying to retrofit into existing buildings and systems, so we wanted to make sure there was the ability to do that. And we also wanted to account for energy storage. So that is basically a very long definition, but I feel like it's very inclusive of anything that is happening now or could happen in the future. So what is included in this section of the standard is mostly the distribution piping system, which is very different than the piping systems we use for like one building with ground heat exchanger. There's only certain materials that you can use, but when you do a district system, there's a lot more flexibility in the way that you can put those different pieces together. What is excluded is we don't talk about the ground heat exchangers or anything like that because those are already covered by other parts of the standard. So this is really talking about the distribution system and those pieces of the district energy system which would not be found in maybe, a typical building. So we deviated slightly from the format that Mark showed you initially that we tried to stick to with all the other different sections, commercial, foundation, heat exchangers. We have a very lengthy project planning section because if you heard the speakers this morning with developers, there's all kinds of things that need to be considered. And so we spent a lot of time kind of developing the master planning, pre-planning, all of the site surveys, all the things that you're going to need to do with these kinds of projects because you're crossing boundary line or property lines and things like that. It becomes more complicated. So our attempt here was to provide some guidance, maybe not so much maybe verging more on the side of guidance rather than standard, but we wanted to start equipping designers with the language and get at least alerting them to these are the things you need to think about with your designs. These are a list of materials that would be acceptable for distribution systems, for district energy systems. You will find these in your mechanical codes, whether it's IAPMA or ICC or something else in Canada. What you will see not here is CPVC and PVC. That's something we took off the board for both ground heat exchangers and for distribution systems. Certainly the authority having jurisdiction could overturn that. That's their prerogative. But this, even though you go to your code and you see that PVC and CPVC is there, it is not in the standard. It is not permitted. The other thing that you have to think about with these distributed systems is that, especially in cold regions, you do still need to look at pipe insulation. I know the ambient temperature loop systems are very popular, and a lot of those don't have insulation, but I think that as designers, we still need to look at that. We need to look at the ground temperatures. We need to look at the burial depths. We need to look at all of those things. And so there's some guidance, some recommendations, some standards reference to. If you wanted to use a pre-insulated piping system, those references are also in the district energy section of the standard. And then there are a few pieces of material, under Clause 5, we deal with equipment and materials typically used for these systems. There are a few things different with district that you're not going to see for a typical building, and so there's some discussion about energy transfer stations, communications. You may not just have a building management system, you might have a SCADA system, so there's a lot more. There's a lot more to think about with these district energy systems. We also have some thermal energy storage covered within this part of the standard. Okay. The other addition that we had was an annex, and I volunteered to do this one. I didn't quite volunteer for the other one. I think I was more like appointed. But in any event, I was really interested in learning how these wastewater energy, we call it wastewater energy transfer because you can say wet It's kind of an acronym we hope will get picked up. But anyway, wastewater energy transfer systems can be done a lot of different ways. And so this first diagram here is showing a pumped heat exchanger system where you could take the heat out of raw sewage, pump it through a heat exchanger, and exchange that energy with, say, a building to preheat hot water or something like that. Likewise, you could do that outside of the building. I think they're doing that in some projects in Colorado, and I'm sure many other places where they're actually tapping into the distribution system and pulling that heat out and using it as part of a more of a district-type system. So that's one way that you can do these systems. The other way is an in-pipe where you're actually trying to just recover the heat out of the pipe as it is distributed to the waste water treatment plant. And so we wanted to make sure that we featured all of these technologies and provided a little bit of guidance to the designers on how those might be used. There isn't a lot out there right now on this technology. It took a while. We found a reference out of Germany, and thanks to our partners, I feel it was really an international task force. We had people from Germany and England and Canada and the United States working on this annex. I was able to go purchase this German document that I could not read, and then we brought it here. It was translated for us, and we were able to reference some of that information in that very good document. This is more of a guideline, but there was some good information there. So if you wanted to learn more about this, I provided this reference here so you could go get that document for yourself. And so in a nutshell, that's the new annex. As Mark said, it's mostly informative, but it could be that because of interest in the industry or lack of, it may or may not be picked up in the body of the standard during the next revision. And now I'll give it back to you.
There we go. Okay. Yes.
Yeah, under the geothermal environment, you're boring into the ground. And ground is simply a heat exchanger. That's my understanding. And you have a set of codes and standard you apply. On the other side, under the drilling/fracking environment, you're also drilling into the ground. Is there any different code applies to fracking/drilling versus boring? And if so, what will be that difference?
You're going to have different codes that are going to be applicable to oil and gas, fracking as an example. They have their own set of protocols. A lot of it goes under a mining act. It depends on jurisdiction. You have another area where you have water wells. That's, again, different than what we do as a geothermal or GeoExchange borehole. Those are separate pieces of legislation, and they do not impact what we're doing on the geothermal side. With the caveat, we always make the distinction on these are not wells on a closed loop system. It's imperative that everyone understand that. However, if you have an open system, as an example, in a geothermal world, a pump and dump they're called, right? Where you're extracting water, running it through a heat exchanger, and either re-injecting into the aquifer or discharging to surface, that is a water well, and that falls under water well regulation. So we've taken that into consideration in the standard. We defer to the authority having jurisdiction with respect to a water well in a particular geographic area. Does that make sense? Yep. So where are we now? We're just about done, so we'll let you go here pretty quick. In Canada, and again, bear in mind, we're dealing with two countries, obviously, so two different jurisdictions and how they do standards. So in Canada, we have the Standard Council of Canada. They have a prescriptive methodology on how you do things. So that went out for what's called public review, and that finished on August the 6th, 2024 in Canada, or under a CSA overall umbrella. In the United States, it's a little bit different. ANSI has its own protocols, and we're currently right now out for public review in ANSI. That's a 45-day process. I'm sorry, I don't know the exact date when it ends, but once that is completed, then any of the public review comments will be looked at, and we do what's called a disposition, meaning something came up from, you know, Bob or Betty, whatever the case may be. What about this, that, or the other? We look at it. Is it germane? Is it something that we have to re-look at? We've missed the boat, possible. I mean, you know, never say never, or it's not. We have to do a disposition so that the public review comments have been satisfied. At that juncture, it's going to be going through a final edit and so on and so forth. Then it goes to production, and unfortunately, this is out of date because there was some hiccups. We thought it was going to be December 2024. It's going to be pushed by about a month or two. We're not quite sure yet. Excuse me. Again, looking back to what we were talking about, what you guys brought up with the IGSHPA standards, they will be sunset on publication of the new C448. We have, I think, consulted with as many people as possible. We're very open to suggestions. The whole IGSHPA subcommittees went through the 2016 edition, brought forward, 30, 40 pages of recommendation. We looked at them and went, yep, that's good, that all makes sense. The idea was to amalgamate this and have one standard in hopefully North America and hopefully the United States that everyone is adhering to. That's where we're trying to go. We're also looking, as I said earlier, there are going to be changes in this industry that we will not be able to capture with the 2025 edition. We have the whole issue around new refrigerants coming on, the A2Ls, et cetera. Performance spaces, where it's going to sit, and to bear in mind that the C448 standard is not on heat pumps, not on the equipment. So bear that in mind, right? It is a total system, but the C448 is concentrating on the heat exchanger part of the system. So basically, that's where we're going to conclude, but I'm sure there may be some questions, and please fire away. Ultimately, we want this to be a North American standard, so we're all doing the same thing and we're growing the industry. And just because there's a border between our two countries doesn't change the immutable laws of physics or good practice. So with that, we'll take some questions.
Hey, thank you, Mark and Lisa. Arlene Anderson, U.S. Department of Energy. I really appreciate your efforts. I'm just curious, will the distribution and costs be similar to how that's currently structured? Like how can, let's say, local code officials get these, and are there different costs? What's kind of the distribution plan?
Well, Arlene, you get a deal if you're an IGSHPA member, so hopefully that's up to date. I don't know the business side of that well. My understanding is it will just continue. As an IGSHPA member, you'll get a discount on the standard. You can get it in print, or you can get it in a PDF, and it'll be widely available on the CSA website. It will be, again, should this get into a code here in the United States, you would be having access to it through an ICC or an IAPMO should either of those bodies decide to adopt. I mean, we want to spread the word. It's as simple as that, right? So the pricing I don't think is going to change, but I'm not the guy to ask. I'm sorry.
Yeah, I was curious specifically on the PVC topic. If you're in a region where antifreeze is not needed, is it still a problem to have PVC, or has it been found to be problematic?
It was, we looked at it very, very seriously through the piping task force, and trying to put language in where you have caveats like that. I know where you're going. It's like if it's a water system only is what you're getting at, correct?
Right.
Right. It would have been very problematic to do that, and on the balance, there are not that many systems out there that are water only. So a decision was made. We drew a line in the sand saying PVC and CPVC should not be in these systems.
It's more about the expansion and contraction of the piping system and how over time, I like in my own experience where that has been done, the system fails very quickly. So we just want to set our industry up for success. And so there are plenty of other materials that can be used.
Okay, thanks.
It's got all the steps happening.
How many steps have you had today? John, did you make your 10,000 yet? Okay.
So I have a pretty specific question. I've seen a lot of these downhole heat exchanger variants that take advantage of advective flows. So you've got these, I don't know, dynamic convective closed loop systems coming onto the market. Is there any additional narrative in CSA C448 for that in the 2025 version?
You meaning in respect?
There's so many of these now. There's units coming out of Europe, coming into the North American market, and we've seen them come out of Asia Pacific into the North American market, and they're a closed loop HDPE that's going down into basically a shell and tube heat exchanger with a pumping system. So have you expanded language on that?
Basically, it's the material that's going to be in the ground, right, is going to be what we've already specified with HDPE, PEX, HDPE raised temperature, yeah, and PERT. I mean, that's basically the acceptable materials in the standard. So if you're talking about some innovative new type of heat exchanger, to be standard compliant, they have to be made from those materials. That said, we're trying to keep things as open as possible. We have yet to see what you're talking about introduced here in a meaningful way. Should that happen, and should there be a big push, we can relook at that area of the standard. That ability exists. At this juncture, that's not there. I mean, there is some of the European heat exchangers coming over. Appreciate that. Some of the coaxial designs, so the pipe within a pipe. Again, so long as those are made from HDPE or PEX, et cetera, they're compliant, right? We're trying to make sure that we're not putting a barrier to innovation. That's not the point here. But we certainly don't want to have substandard materials in the ground. Bearing in mind, we are putting infrastructure in the ground. We have to look at it that way. It's going to be there for 50, 100 years. We want to make sure it's put in with the right material that won't, deteriorate over time. Is that?
Okay. Greg Kurtz, Technical Director with IGSHPA. I wanted to add one thought about the PVC question, CPV piping. You want to check also, some manufacturers that have equipment require on some of their equipment that you not just put water systems out there. They want antifreeze in their system for their equipment. So keep that in mind when you're doing heat exchanger designs, what kind of equipment's going to go on the job and what the equipment manufacturer would require also. That would impact your thought process possibly.
Hey, Greg again from Con Ed on the thermal network side. So in the last few years that we're in this space, right, see what was done before, and then I'm assuming not by chance, there's an EN-448 in Europe that has a lot of similar themes in this space, and this is C448. How, I guess, and how departed or close are the standards here based on or tied to any of the European standards that are in this space, and how different are they? Because as we start to see a lot of vendors, whether engineering firms, drillers, manufacturers, piping manufacturers start coming over, we see a lot of EN-448 or other type of standards. How do they tie, or are they tied, or how close are we doing what we're doing here in North America to what's been, seems to be done for perhaps longer in Europe?
The short answer, Greg, is they're not tied. Are they going to be similar? Yes, because the technology is similar. We are not taking a European standard which would usually be an ISO standard or a DIN standard, depends on which EU country is adopted to what. We're not doing that. It's too messy, right? If people want to come from the EU over here to North America or from Asia, they're going to be compliant with this standard, and as an example, with our piping size. It's a big issue, right? A European millimeter size metric SI and an IP do not match, even though they can be close. We have to be cognizant of our market here and what we can effectively put in. If someone wants to enter the market from Europe or Asia, I mean, obviously, we encourage innovation on all that kind of stuff, but be compliant with North American standards. When you're not, our view is you run into problems. We want, standards are to standardize. So we're not having, as the gentleman said, the Wild West. We don't want that. We want to make sure you as a utility, you want to have confidence that what's going in the ground is going to be there for a long time. You're a utility. You're not somebody that wants to be constantly repairing things or, oh gosh, we used the wrong product, right? So sorry to be long-winded, but Europe is doing its own thing. We appreciate that. They're very innovative, and those innovations will migrate to North America, but they got to be compliant with our ASTM standards, et cetera, and with C448.
So in the general section, there's a whole listing of references of other standards that we reference to this standard. ASTM, for example. There is one EN standard. I don't think it's 448, it might be, but anyway, it's referenced for the pre-insulated piping systems. And so if you go in there, you will see what other standards are referenced, but they're not, it's more of a material type standard, not installation like what we have here.
Yes.
Hi, Angela from Columbia University. So it seems like there are a lot of really valuable changes coming up in this upcoming standard. What would you recommend for a system that's currently in the design phase that's going to wrap up before this new standard is published? I mean, are there any other big changes that seem to be coming through other than the material changes and the intermittent testing prior to tie-in?
In comparison to the 2016, is that what you're saying?
Yeah, in comparison
so
to
the
2016.
current one that's being designed is being designed compliant with the 2016 edition, is that what we're saying?
Yeah, so we're in design now. We're going to wrap up probably before the end of December. And I know you said in the beginning
Yeah.
that the new standard was potentially coming out in January, but then you said maybe December. So I wanted to just
That's
find
an
out if there's-
interesting question, because you're sitting right at the cusp. Boy, oh boy.
I think if you're designing to the 2016, I think you're going to be okay.
Okay.
I think, like as an engineer, I always specify that pressure test for that borehole in addition to the whole system pressure test. So I would recommend maybe doing that if you don't already do it as standard practice. But I think the materials are basically the same. The grouting stuff's the same. I think it's more of refinement is what this is doing in addition to accommodating new technologies. So I think you're going to be okay.
You probably want to, if you can, engage someone that is familiar with this to review, just to be sure, right?
Well, folks, we're at time. If Mark and Lisa can hang around, should there be any other questions, that would be great. How about a round of applause? Thank you very much. And at back table, I'll be there if you're looking for the credits.